Go home, I turn the computer on, let it finish encoding, and then I posted it while I'm at home, and I just accidentally hit the wrong group. Okay, what I'm going to talk about today is there's a software package called Logic X right there, and this is the software for that there. There's the instructions. When you install it, one thing that the instructions aren't very clear on, you need to have the serial number of your boot drive. And the way that you get that is you right click on the Windows Start button. I'm assuming Windows 10, that there. You go to Run, and you type Command, and you just do a dir right there. And here is the local drive serial number right there. But you have to go back to a DOS prompt to get that. Because when you run it, when you install it, there's a key generator, and it's going to ask for the hardware ID number. And that's the serial number of that hard drive. And then you put a username there, and then you tell it to generate. So in my case, everything else with the installation is just like a normal Windows installation right here. Right click, Run, Command, dir, and you can't copy and paste, I don't think. 92 EB 4520, something like that, and then you tell it to generate, and there's your serial number right there. So, but the tricky part that some people I found don't realize, where do they get this hardware ID number? And you have to go back to the old DOS prompt, what I grew up with. My first computer came with DOS 1.0. So that tells you how long I've been there. Right there. So that's there. And actually you got to go through that process even if you have the full version of the software, because if the software is found, and I'm going to go to this website here called the Learning Pit. Right here. Oh, yeah, here it is. learningpit.com. Oh. All right. Why is it not working? It says I'm connected. No learning. All right. I don't see an Ethernet cable. All right. This says I'm learning. Let me disconnect and. Detecting problems. Looking for problems, and it says, okay, let's disconnect and try connecting again. All right, well, I guess I won't go to that website. That there. Evan, I have nothing. I've had problems with trying to get normally this will tell me it's not connected, and I have to go to the website and put in the username and password. That there. Today it's not, and probably because I was connected down upstairs through an Ethernet, I unplugged. I didn't shut the computer down. If I shut it and turn it on, that there. Regardless, this is the software that we're going to go through. Now, in here is some training resources. There's some exercises, and right there, and The one that we're going to go through today here is, I'm just going to introduce the, and they don't even show it here as the simulation files. There's a few there's like the or the door simulation right there, and it's empty. Okay. Learning pit. I thought their relay logic. Huh. Okay, the example programming examples aren't there, but if you go to the website, you can find them there. So, and the website is the learning pit dot, and we can't get there. You know what's weird is that the search worked, right? I was able to do the search, and then now I'm disconnected from the internet. That there. So, but it's the learning pit, all one word.com, and right there. And there's some videos on that there. So over the break, if you've got internet, you might want to look at some of these out there. I will give you the software on thumb drive after class, and then that there. So, all right, what the software looks like, as I said, I'm going to keep relatively short today. I'm running a different version, and I don't necessarily have all the files on here, and that's okay right there. I'm just going to, for simulation, I'm just going to today talk a little bit about, here's the I/O simulator. Now, I'm not going to do anything with the BCD, so I'm just going to cover this up here. You've got two things on this window here. On the left side is basically, in order to get this, you have to open this file, the simulation for the I/O simulator. There's a bunch of simulators right there. So, but what we've got here is we've got 2 input modules and 2 output modules. Now we'll come back and we'll talk a little bit more about this, because I really haven't finished my discussion of introduction to PLCs that they're, you know, and I'm kind of jumping ahead to the software. And so part of that is simply because I want to get the software in your hands over the break that they're having. See it there. These are my various inputs. Now, in reality, these would be connected up to real life devices. And I'm going to pull up another one, and we'll go through this one after the break. This is the door simulator. And I couldn't get this to work in my office right there. It had some issues right there. But these simulators, and as you can see there's a number of them out there. We've got 3 push buttons over here. Input 1, these are all the inputs are connected to yeah, let me go back to, I can't have both out there, to module 1 right there. So if you go back to the I/O, you can see we got 16 inputs on module 1 right there. So when we look at the door simulator, we've got our open button on module 1, our close button on module, or input 0 module 1, input 1 module 1, input 2 module 1 right there. We've got a limit switch here, and that's input 1 module 3, or input 1 module, or module 1 input 3, and limit switch 2 module 1 input 4. We've got 2 motors, one that goes up and one that goes down right there. So this is, you know, a simulation, and supposedly I can, you know, put in here an input here, right there. I can put an output on the same module right there, and I can tell that this is I1 I:1/00. That's my open button right there. And this is O:2/00. That's my up motor. So if I run this and run it, we download it into the unit. We can hit the run. And if I hit the open button, the motor is going to go up. Now I got to hold the button in order to get the motor up. That's there. So that's there. Now I can put in here something to make it, I'm going to go ahead and switch this back to where I can program it or finish this. I'm going to go ahead and work on this example here instead of that there. So if I want this motor to run till it opens, I've got to do two things. One thing is I've got to put in a ring. And okay, and then we got to put this inside that there. Then we need to put in another one here. Right here. And we name this one O:2/0. Now, when I hit the open button, it will stay open. That's there. Now, we've got a problem here. In other words, this thing will catch on fire on us when we run. It's kind of cute, but right there. But you'll notice that when I hit the download and the run, and I hit the open button, it continues to open. I have no way to stop it. So when it gets to the top, it'll fire detected. That's there, okay. Clean up. So what we need to do here is we need to put in this. Oh. Take it out of the run mode. Won't let me do anything. So what we need to do is we need to then put in this limit switch here. So this limit switch, and we'll just click on that there, and we'll put in the limit switch right here. It needs to be outside that little feedback loop right here. And we're going to then basically say, call this I:1/03 right there. So now when we open it, it will stop at the top right there. So we flip it back around, we download the program again. Now this is simulating the fact that in real life you would actually take your laptop out and you plug it into the PLC module and you would actually go through the program. This is all a simulation right there. So we could go ahead and put this in run mode, and we can hit the open button. And we got a problem because this should be an open normally. That's there. This is not showing this button there. Let's go ahead and hit program, and let's change this to this here, and then we'll go back and download it again. I put the wrong one. Sometimes it's just trial and error right there. I don't know whether this is normally open or normally closed switch. Right there. So it's downloaded and run. Yeah, see now it's active. And the good thing about the simulator is you see the yellow. So this is a normally closed switch. So when I get to the top, it opens right there. So if I hit the open button, garage door opens right there. Right here. When it gets to the top, that switch will close or open, and we can see there that the garage door stops right there. So now if we want to close the garage door, we need to repeat the process. That there. I actually was going to do this assignment, but since I started, I might as well go ahead and do it. It's more interesting than just flipping the switches and seeing lights come on right there. Right there. So we flip it back to program, go over here, and we put in another leg here. Now, one of the things we want to keep in mind is that we don't want the up and the down motor to be on at the same time. So we need to fix that there. Well, let's go ahead and do the down motor, and I'll show you that if we don't put those little brakes in there, then we have a problem. So let's go ahead and put in a new rung right here. So let's do rung here, and let's put in our push button. Let's go ahead and put our rung in here. Let's go ahead and select this here. Let's go ahead and put right here. Let's go ahead and put, oh, we need to put that there. And let's go ahead and put in, now it looks like this bottom one is a normally open one. So we probably need to, yeah, that's the same up there. So we need to put in a right there. Now let's just go ahead and put our inputs in. So our close is I:1/01. Our motor here is output module 201. That's our down motor. Our lower limit switch is I:104 right there. And our motor is O:201. So this is almost finished. I can open and close my garage door right there. So let's go ahead and program it. Now we've got some problems yet with it. We'll talk about those in a second. Run. And we've got a problem I can see right now is that this one here is active. So that tells me that that particular one, I need to change to a, right here, so to a normally closed. So, and the way I can tell is the garage door is open and the limit switch is showing that it's inactive. That there, so I had to change that there. Both these that there. So now when I run this, if I hit the open button, nothing happens because this limit switch is limited. If I hit the close button, the garage door will close. So we're in good shape right there. So it closes all the way. And I couldn't get this simulation to work with an old file I had, so evidently there was something wrong with it. Had to start it from the beginning, then it works. So no problem, right? And then we can open it again, and it opens with no problem. Now the problem is while it's opening, if I hit the close, it catches fire. And the reason it catches fire is because both the up motor and the down motor are on at the same time. So we have to put in a sensor to, or something into our ladder diagram in order to say that if the down motor is on, don't go up. If the up motor is down, don't go down right there. In other words, so I'm going to go ahead and put this back in program mode, and I'm going to put in each one of these right here, and I'm going to call this O:2/1. In other words, the down motor can't be on in order to turn on the up motor. And then I'm going to do the same thing here as I'm going to, in this run here, I'm going to also put in the up motor. So output :2/0 right there. So now when I run it, if I hit the up motor, if it's going up and I hit the down button, it's going to ignore that right there. So download this. I hate to admit this, but normally I practice this before I come to class. I didn't practice this one, so I'm doing it off the top of my head. That there. So, all right, go ahead and put it in run mode. Now, in run mode, it's already down, so I can't hit the down button. It's going to ignore the down button right there. Close button. And we can see that because this limit switch is right there. So we hit the up button, or the open button. It's going up. Now, if I hit the close button right there, you'll notice that it won't go down. It doesn't catch on fire. It ignores that because this motor is on right there. Now, what I don't have yet in there, and I'm almost done with this example, and then I'll call it a day. That there, my head is starting to say I've had enough of that there. I need to have a way to put the stop button in there. So, and the stop button's actually fairly easy, and we just put in both these right there. So, we're just going to go ahead and we're going to put the stop button in both sides here. So, let's go ahead and put in our, it should be a normally, and I'm just going to put it in the beginning of each one of these. Right there. And that is, the stop button is I1/02 and I1/02 right there. So now this should complete this garage door right there. So if we go back to my run, program it, we run it, right there it's running. We hit the close button, and guess what? The stop button is the other one, normally closed, so I need to go back and change that. In this particular case, I'm working with the problem is that I don't know whether these are normally open or normally closed switches. So if I just change both these, and the color may have something to do with that there. Fortunately, that's a common mistake, so they make it an easy fix. I'm just right-clicking the mouse, and it gives me that there. So, and this is why I practice, so that I look like I don't make these mistakes off that there. But it's okay. I mean, you can see how you fix those mistakes, how easy they are. And when I hit the run button, I could tell right here that these are active right there. In other words, that button is is active, which is what it needs to be in order to do that. So if I hit the close button now, the door closes. I can hit the stop button halfway down and it stops. I can open it back up. I can't hit the close button until I hit the stop button. I can close it and it goes all the way back down to the bottom, right there. So, and it's a slow garage door, right there. But you can see all the various components of this particular one right there. So, this is not unlike a small project, that you would do. And I would say that you should expect something similar to this on the final exam, that type of question. It may be something, a part of this out there, but it's out there. But that's basically the introduction to the software. And it's a pretty good little introduction to how we do ladder logic. Now, I'm doing this without drawing a flow chart or on paper. I'm just sitting down. But to be honest, most experienced PLC designers, that's what they end up doing it anyway. You look at one output and you try to figure out piece by piece what all we need. Without this discussion, you look at this drawing, it probably doesn't make any sense. But as you go through the steps that I went through to add each piece to it, then it should start making a little bit of sense. Now, granted, it's going to be a week and a little over a week before I see you again, so I don't want to introduce anything more than this because I'm going to have to repeat probably this lecture when I come back, at least highlights of it that there. So I'm going to quit at this point here. I'm going to say my shortest lecture, I think, in this class, isn't it? 30 minutes up there. So, but have a good spring, or I'm sorry, I'm still thinking U.S. April usually we have is springtime in the U.S. and we call it spring break, right there. And if you watch any American movies of college students, you've heard the term spring break before. Normally, most Americans go to the beach and they do things that you shouldn't do. I didn't do those things back when I was in college because I went to college later in life. I did 4 years in the military. I was in the Air Force for 4 years. And then I went to college after I was married and had kids. So I didn't go to the beach and chase girls, in college. I was already married with kids. I'd done 4 years living overseas in the military, and we won't talk about what military life is, but it's not there. But I did that. So, but regardless, have a good spring break, and those of you that are going